Students, good morning. This is your class number 4.5, in which we are going to solve one problem on this roller type of a follower. So you can see in this animation, the type of follower is of a roller type. So you can compare with the previous problem, which is having a knife edge follower. It means whatever I solved, problem number 1 and 2, they are of a knife edge type. But in this case, I'm going to solve one problem on this roller type of a follower. And again, you need to design this cam profile. I have taken an example. So it may be of any shape, but as per given requirement, you have to draw the cam profile of this camshaft, around this camshaft. And this problem is very important from exam point of view. Okay, and let's get started with the problem. Yeah, so please note down this problem. Just note down the keywords wherever required. Yeah. First, I'll read out this problem, and after that, I'll note down the given things. What are the given things? Problem number 3. A cam rotating clockwise at a uniform speed of 300 rpm operates a reciprocating follower through a roller 1.5 centimeter diameter. It means you can see here the cam is rotating in a clockwise direction with uniform speed. So the cam is rotating with uniform speed in a clockwise direction, and the speed of the cam is given as 300 rpm, means 300 revolution per minute. It is uniform, it is constant, there is no variation. And it is connected to a follower, and this kind of a follower is nothing but a roller follower because it is mentioned. You can see here. So they are given the roller diameter. So they are not mentioned it is a roller follower, but instead of they are mentioned a roller follower, the diameter of the roller, that is 1.5 centimeter. So this pink color is nothing but the roller. Can consider as a disc also, a circular disc, and the diameter of this roller is of 1.5 centimeter. Remember this parameter. After that, with respect to this cam, the follower starts moving in upward and downward direction. The follower motion is defined as below. And what is the kind of follower motion? During upward and during downward stroke. So the first one is outward during 150 degree with a uniform acceleration and a retardation motion. Just wait for a second. Some more students want to join this meeting. Yes. Yeah. The first condition is the follower is moving outward during 150 degree with a uniform acceleration and a retardation motion. You can see for the first 150 degree rotation of this cam from 0 to 150, the follower is moving in upward direction with uniform acceleration and a retardation motion. So this is given. And after that, dwell for the next 30 degree. After the follower moves in upward direction, it will not come suddenly in a downward direction. After moving up, it will take some rest, then come down. Up, down. It means in between the rising and the downward motion of this follower, it will take rest. Okay, you can see here upward motion, rest, downward, rest, upward, rest, downward, again rest. It means for the first 150 degree, the follower is moving in upward direction. After that, dwell for the next 30 degree. Okay, for the next 30 degree of cam rotation, there is no movement of the follower. It means the displacement of the follower is zero, which is called as a dwell. After that, return during next 120 degree with a simple harmonic motion. And for the next 120 degree of cam rotation, the follower is coming down with simple harmonic motion. So it is also given. After that, the fourth one, dwell for the remaining period. So what will be the remaining period? Anyone? Total is 360. Ali, you have covered 150, 30, and 120. What will be the remaining angle of the cam? Anyone?
60.
Correct, 60. Because 360 minus summation of all these things. You can see here 150 plus 30 is 180. 180 plus 120 is 300. It means 360 minus 300, 60 degree. Means for the next 60 degree, there will not be any movement of the follower. That's why it is called as dwell.
Well,
Correct. Yeah. So these are the four angles already given in the problem. And one more parameter is given as a stroke of the follower is 3 centimeter. Stroke is nothing but the distance traveled by this follower, the maximum distance from this point to this point. So it is covering maximum of 3 centimeter, which has to be indicated with alphabet S. And after that, a minimum radius of the cam is 3 centimeter. So whenever the word comes minimum radius, it is nothing but the base circle radius. Okay, it is a imaginary circle with respect to which we are going to draw the cam profile. Okay, so just remember, whenever the word comes minimum radius, it is nothing but the base circle radius, and it is given as 3 centimeter. After that, you have to draw the cam profile for the following cases. Again, the cases remain same. The first case is nothing but with respect to the radial follower, and the second case will be with respect to the offset follower. It means follower axis passes through the cam axis. So this is nothing but the example of a radial follower, in which you can see the follower axis and the center or the axis of this camshaft are in the same line. Okay, they're in the same line. So this is the first case, and the next case is the follower axis is offset to the right by 1 centimeter. It means slightly I'm to shift this follower towards my right in such a way that the follower axis will come here and the camshaft axis will be here. There will be a gap between the follower axis and the cam axis by 1 centimeter. Okay, since it is towards right, I'll move this follower towards right. If it is given the problem as left, you have to move towards left. That is the only change. Okay, just confirm all these things. Also, you need to find the maximum velocity and acceleration during the outward and return stroke. It is also similar to the previous problem. Only the change is, you can see here, there is one extra parameter is given, that is a roller. It means the type of follower is roller type of follower. Okay, please, before you start with the problem, just confirm all these things because it is a 20 marks problem. Okay, if you do any mistake, instead of taking a roller type of a follower, if you take a knife edge, okay, you'll not get any marks. Okay, and after this, we'll go to the next slide. First, I'll write down the given things. As given in the problem, the stroke length is nothing but S, that is a 3 centimeter. So you can see here it is a stroke length of the follower. And one more parameter, that is nothing but the base circle or the minimum radius, that is also given as 3 centimeter. I'll take it as a capital R. And one more parameter, that is a roller diameter. Okay, the diameter of the roller follower is given as 1.5. So usually I want a radius of that roller. Okay, so it means 1.5 divided by 2. So I'll get the radius of the roller as a 0.75 centimeter. Okay, and the speed of the cam is given as a 300 rpm. I'll take it as a capital N, and it is also given as a clockwise. It is also important whether it is rotating in clockwise or in anti-clockwise. And after this, the first angle is the theta naught, the outstroke angle, that is 150 degree with uniform acceleration and retardation motion. And first dwell angle, that is 30 degree. After that, the follower will come down for the next 120 degree of a cam rotation, that is denoted as a theta r with a simple harmonic motion, and dwell for the remaining period. It means 360 minus the summation of all these three angles. I'll get theta d2 as a 60. Okay, and since it is given as the follower is offset towards right in the second case, you have to draw the offset circle during the design of the cam profile for the second case. So for that, you have to draw the offset circle also. So that radius will be 1 centimeter. I have taken this from this 1 centimeter because in the second case, you need to draw offset circle. Okay. So since it is towards 1 centimeter, I'll take the offset circle radius as 1 centimeter. Yeah. And one more important parameter is this. Please note on this prime circle radius. So this is very much important when the type of follower is of a roller follower. Remember this. Okay. Whenever the problem is of a roller type of a follower, so this comes into picture. That is a prime circle radius, which is nothing but the summation of a base circle radius, that is 3 centimeters, and the roller radius, that is 0.75. 3 plus 0.75, it becomes 3.75 centimeter. So this is very much important. While drawing the cam profile, we're going to consider this prime circle, okay, and we're going to neglect this base circle. In the previous problem, whatever we have solved, we have taken the reference as this base circle. With respect to this only, we are going to divide the circumference of the circle into 6 equal parts, correct, for the outstroke and the return stroke. But in this case, just remember, we're going to neglect this base circle. Instead of that, we'll give importance to this prime circle radius, because there is one more radius, that is the roller radius is added. So it becomes 3.75. It means the summation of base circle radius and roller radius is considered as a prime circle radius. Please make a note of this. So I got 3.75. So till now, if any doubt while writing the given data, please let me know. Otherwise, directly I'll go to the solution. Yeah, I think this is clear. I'll go to the solution. First, I need to calculate the maximum velocity and maximum acceleration during outstroke, return stroke. Out of these three set of formula, which one I have to choose? So it is given in the problem. The outstroke is with uniform acceleration, remember, and the return stroke is with a simple harmonic motion. So first, I'll find the maximum velocity and maximum acceleration with respect to the outstroke. Okay. And what about the outstroke? The outstroke is with uniform acceleration and retardation motion. So I'll not consider this. I'll not consider this. I'll go with this one, because the outstroke is with uniform acceleration and retardation motion, which is given in the problem. I'll select these two formulas and I'll find the maximum velocity and maximum acceleration during outstroke. V0 is nothing but the maximum velocity during outstroke. A0 is nothing but the maximum velocity acceleration during outstroke. After that, it is given the follower will come down. It will return back with simple harmonic motion. The kind of follower motion is simple harmonic. So that's why for return stroke, I'll consider this one. So you can see here, that is simple harmonic motion. For return stroke, which is with the simple harmonic motion, I'll consider these two formula. So please note on these four formulas. Okay. And you also know how to calculate the angular velocity, that is omega, which is equal to 2 pi n by 60 and should be in RPM. Okay. And theta naught and theta r should be in radians. Just please note down these four formulas so that I can calculate maximum velocity and acceleration during outstroke and during return stroke. Yeah. First, I'll try to find out these maximum velocity and acceleration during outstroke, which is with a uniform acceleration and a retardation motion. I'll copy this formula. So for this outstroke, you can see here. So I have copied these two formulas, that is maximum velocity and maximum acceleration. To find out these two parameters, so I want this value, the angular velocity. S is already known, theta naught is known, theta, okay, the S is also, this is also known. And the unknown thing is omega. Using this formula, I'll calculate omega is equal to 2 pi n by 60. N is given as a 300 RPM. So I'll substitute. I'll get the answer as a 31.42 radian per second. After getting these value, I'll substitute in the the velocity formula. That is equal to 2 omega s by theta naught. Omega is nothing but this 31.42. S is nothing but it is given as a 3 centimeter, the stroke length. Just convert into meter. it becomes 0.03 or 3 into 10 raised to minus 2. Both are correct. After that, I'll substitute the value of theta naught, the outstroke angle, which is given as 150 degree. But I want in radians, so I'll multiply with pi by 180. So finally, I'll get the maximum velocity as the 0.72 meter per second. In the similar manner, I'll try to find out the maximum acceleration during outstroke. So I'll substitute the value of omega, that is a 31.42, the whole square. S, it should be in a meter, that is 3 into 10 raised to minus 2, or you can substitute 0.03. And theta naught is again 150 into pi by 180 whole square. I'll get the maximum acceleration during outstroke as a 17.28 meter per second square. This is the case of outstroke, which is with uniform acceleration and retardation motion. Then I'll go to the return stroke, which is with a simple harmonic motion. For that, the formula is this one. I got this formula from this simple harmonic motion. That is nothing but pi by 2 omega s divided by theta r. The same formula I used. Again, I'll substitute the value of omega, that is a 31.42 from here. So again, the value of stroke length, 3 centimeter, just convert into meter. Again, the theta r is given as 120 degree. Okay, the theta r is given as 120 degree. Just convert into radians by multiplying by pi by 180. So you'll get the maximum velocity during return stroke, that is Vr max, as a 0.70695 meter per second. After this, I'll find this maximum acceleration during return stroke, that is a pi square by 2 multiplied by omega square s divided by theta r whole square. Just substitute the value of omega, the value of s, value of theta r, that is 120. You'll get the answer as the 33.32 meter per second square, which is nothing but the maximum acceleration during the return stroke. So please verify your answer, whether you are getting the similar answer. Please check. Please take a 30-second time. Just let me know. Anyone from fourth semester C division? You're getting the similar answers? Fourth semester C division. Anyone from other divisions? Fourth A or fourth B? They can reply. Otherwise, I'll move towards next slides. Yeah, I hope this is clear. I'll go to the next slide. That is nothing but a displacement diagram. Displacement diagram. It is also same whatever you have drawn for the previous problem. It is also same. Only change is the outward motion is with uniform acceleration and retardation motion. So you have to use that method. I have explained this method during the previous problem. And the return stroke is with a simple harmonic motion. Again, use the semicircle method. But in this case, since the outward motion, the simple harmonic motion is with respect to the return stroke, I'll draw the semicircle towards my right side because it is convenient for me. If you want, you can draw here also, and you can extend the lines. But since it is convenient and it is easy for me, so I'll draw this semicircle method. Okay, I'll use this semicircle method towards my right side because the outward motion is with the return stroke is with a simple harmonic motion, and the outward motion, that is the rising of the follower, is with a uniform acceleration and a retardation motion. Okay, so already I have explained this in the previous class, so I'll use the same thing. So first I'll try to indicate all these angles, that is theta naught, theta d1, theta r, theta d2 along x-axis. And along y-axis, I'll plot that the displacement of the follower, that is a stroke length 3 centimeters. Okay, again the procedure is same. After indicating all these angles, you need to divide the outstroke into 6 equal parts, and you have to give the namings from 0 to 6. Again for the next 30 there is a dwell. Again for the next 120 there is a return stroke, which is with a simple harmonic motion. Again use the same method, just divide the 120 into 6 equal parts, use the semicircle method, you'll get the answer. Yeah. I'll start with this displacement diagram. I want to construct all these things. Yeah. Again, I'll take the scale as x-axis 1 centimeter is equal to 20 degree, similar to the previous problem. Y-axis 1 centimeter is equal to 1 centimeter stroke length. So along the x-axis, I'm going to plot cam rotation angle, the angular displacement of the cam. So since the total angle that is covered by the cam is 360, it means 360 by 20. I'll get 18 centimeter line. First, I'll draw a 18 centimeter line along x-axis. And along y-axis, I know the stroke length of the follower, the maximum length, which is nothing but S, that is a 3 centimeter. So I'll indicate a 3 centimeter along this vertical axis or y-axis. After that, I'll join all these things so that I'll get a rectangle of size 18 centimeter by 3 centimeter. Then I'll plot the first angle, that is 150 degree. So how to plot this? 150 by 20, I'll get 7.5 centimeter, right? It will be 7.5 centimeter. You can see. So I'll indicate the angle also. The outstroke angle is with the 150 degree with the uniform acceleration and the retardation motion. So 150 degree divided by 20. As per the scale, I have to indicate 7.5 centimeter. After that, for the next 30 degree, there is a dwell. Means 30 by 20, you'll get 1.5 centimeter. You'll get 1.5 centimeter. 30 divided by 20. So after that, for the next 120 degree, there is a return stroke. For the next 120 degree, there is a return stroke. 120 degree means 120 by 20. Again, it will become 6 centimeters, which is nothing but with a simple harmonic motion. After that, for the next 60 degree, there is a dwell. So 60 degree divided by 20 degree, I'll get a 3 centimeter. So this is similar to the previous problem, only the angle, the value of angles is different. And one more thing is, you can see the type of follower's motion is reverse, completely reverse with respect to the previous problem. The previous problem, the outstroke was with a simple harmonic motion. The return stroke was with a uniform acceleration and a retardation motion. But in this case, I have interchanged them. In the problem it is given, the outstroke is with uniform acceleration and retardation motion. The return stroke is with simple harmonic motion. It means the method of drawing the displacement diagram is also changes. Just you have to reverse the method or whatever you have followed in the previous problem. That is a problem number 2. That is the only change. First, I'll start with this uniform acceleration and retardation motion. First, I'll complete this. After that, I'll go to the simple harmonic motion. And what is the next procedure? You have to divide this outstroke angle, that is the 7.5 centimeter, into 6 equal parts. So what will get? 7.5 divided by 6. What will be the each division? Just calculate. I want 6 equal parts of this total length 7.5. And even 7.5 divided by 6.
1.25.
Correct, 1.25. It means each division will be 1.25, 1.25, 1.25. After that, I'll give the namings 0, 1, 2, 3, 4, 5, 6, which indicates the 6 equal parts. 0, 1, 2, 3, 4, 5, 6. Now only you can divide this simple harmonic motion, otherwise you can do later also. First, I'll try to complete this one. And you know,
1 centimeter, sir.
yeah, before that, before dividing this, I'll go to this one. You can do that also. First, I'll try to complete this. And you know the method to draw the displacement diagram for when the motion is uniform acceleration and retardation motion. Since the outstroke means the follower will be rising, the curve will be in upward direction. It will be rising like this. So that what I will do, before that I'll take the middle line. The method to draw the displacement diagram for this uniform acceleration and retardation motion is, out of these 6 lines, is considered the middle line. So this one, the line number 3, the vertical line 3, and divide this into 6 equal parts. So what is the height of this middle line? That is 3 centimeter. I want 3 equal parts. Sorry, 6 equal parts.
0.5, 0.
Correct, correct. 3 by 6 is 0.5. So each division will be 0.5, 0.5, 0.5, 0.5 centimeter. And I'll give the naming A, B, C, D, E, F. A, B, C, D, E, F. So this is the procedure. Whatever I solved in the previous case, just try to remind those things. Okay, this method is standard. Whenever you see the word UARM, so out of these 6 lines, just take the middle one and divide that into 6 equal parts. The height is 3 centimeter. 3 by 6 is 0.5. Hence, you can see the curve is going in an upward direction because it is rising. Outward means the follower will be moving in upward direction. It means the curve will be rising like this. So that's why I'm to start from this point and I'm to end with this point. It means I'll start from a left bottommost corner and I'll end with the right topmost corner. It means first I'll draw the diagonal passing through this point C. So like this and like this. Because the curve is moving in upward direction. So first I'll indicate this diagonal. So from this point to this point, and it is passing through the point C. And after that, again I'll start from here. I'll join A also, I'll join B also. Like this. Like this. And again, I'll take this as a reference. I'll join point E also, point D also. Like this and like this. So this is the standard method. You have to remember this. First, I have started with a diagonal passing through point C, and I'll take this as a reference point. This is also one more reference point. I'll join this point to this A and B, the straight lines. Again, from this reference line, I'll join point D and point E, like this and like this. Okay, and the next step is, you can see the first inclined line. This is nothing but a blue color line, the first one, which is joining point A. So this will intersect the first vertical line, which is numbered with a 1. It will intersect at this point. So you can see at this point it is going to intersect. I'll indicate it as a 1 dash. And the second inclined line, which is joining point B, it will intersect the second vertical line at this point. I'll indicate this as a 2 dash. And this will be the third inclined line, which will intersect the third vertical line at this point. This will be 3 dash. And this will be the next inclined line, that is the fourth inclined line, that is joining point D. So this will intersect point 4, the vertical line 4 at this point. The intersection point will be 4 dash. And similarly, the inclined line which has started from point E, this one, so it will indicate the fifth vertical line at this point, which is nothing but 5 dash. The last one will be 6 dash. Okay, please try to zoom this area. So I'll indicate the intersection points. You can see the red color points. These are nothing but the intersection points between these 6 inclined lines and the 6 vertical lines. I'll give the naming 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, and 6 dash. And we have used the same method for the previous problem. And after that, I'll draw a smooth curve passing through all these lines, like this, the red color line. So this is nothing but the displacement diagram for the outstroke angle. Means whenever the cam is rotating through 150 degree of rotation, the cam will be moving from 0 to 3 centimeter. Okay. So for the first, you can say for the first 20 degree, it is moving some distance. For the next 20 degree, you can say it is moving certain distance. We're plotting the displacement of the follower against the cam rotation angle. So this is the smooth curve. Okay. So this is nothing but the uniform acceleration and the retardation motion curve. So after that, for the next 30 degrees, there's a dwell. It means the follower is having a zero displacement. That's why I'm to draw a flat curve up to this point. So this is nothing but the zero displacement of the follower for the next 30 degree of cam rotation, which is known as dwell. After that, I'll consider this return stroke angle, that is a 120 degree, and which is with a simple harmonic motion. I'll confirm this. Since it is a simple harmonic motion, so what is the method that is used for this type of a follower motion? It is a semicircle method. Correct? Semicircle method. Just try to remember, I have solved in the first problem also and the second problem also. So for that, you can start from here also. You can draw the semicircle here also, and you can divide that semicircle into 6 equal parts, and you can draw the horizontal lines. But that will disturb this outstroke displacement diagram. So that's why, to avoid that confusion, I'll draw a semicircle here. Okay. Before that, before drawing the semicircle method, I'll divide this this written stroke, with the 6 equal parts, which is nothing but a 6 centimeter
1
length.
centimeter each.
Correct, 1 centimeter each. 1 centimeter, 1 centimeter, 1 centimeter, and 1 centimeter. Since the curve has to come down, I'll give the naming in a reverse order. That is a 6, 5, 4, 3, 2, 1, 0. After that, I'll draw the semicircle here. So I'll take the midpoint of this vertical line, that is a 3 centimeters. Midpoint is nothing but 1.5 here.
1.5.
Correct. I'll take a compass. I'll draw the arc. I'll draw the semicircle. The radius of 1.5. Correct. And after that, I have to divide this semicircle into 6 equal parts. So this semicircle is nothing but 180 degree. 180 divided by 6, 30 degree. Correct. Correct. Just try to place your protractor over this vertical line. The 0 degree of the protractor has to be in line with this vertical line, and you should place the center of the protractor at this point and divide this into 6 equal parts. It means 30 degree each. And after that, just give the namings A, B, C, D, E, F. So you can start from here also, A, B, C, D, F. It will not matter. Okay. And I have left this displacement diagram here, and I have to continue from here itself. Correct? It means the curve will come down now. And before that, I'll draw a horizontal lines from these 6 parts, that is A, B, C, D, E, F, towards left direction. You can see the blue color lines. Please zoom this area. Just zoom this area. So I have drawn 6 horizontal lines towards my left direction. All these lines, they have started from point A, B, C, D, E, F. Correct? And I have to start from here. So I'll give the naming as a 6 dash, and I'll continue. 6 dash 5, 4, 3, 2, 1, 0. And you can see the line which is coming from point E. It will intersect the 5th line at this point. So this will be the intersection between the horizontal line which is coming from point E and the 5th vertical line. This will be 5 dash. So this will be obviously 6 dash, because I have to start from here. I have to continue from here. So the first reference point will be 6 dash. After that, the intersection between the line which is coming from point E and the 5th vertical line, this intersection will be 5 dash. Similarly, whatever the line that is coming from point D and the 4th vertical line, this intersection will be 4 dash. Similarly, you'll get 3 dash, 2 dash, 1 dash. Yeah. So these are the blue color points, which are nothing but the intersection points between the horizontal lines and these 6 vertical lines. So I got these numbers 6 dash, 5 dash, 4 dash, 3 dash up to 1 dash. And I'll continue this displacement diagram from this point 6 dash with a smooth curve like this. and it has to pass through all these 6 intersection points. So this is nothing but the blue color line, the blue color curve. You can see the curve that is passing through all these 6 points, which is nothing but the displacement diagram for the written stroke angle, for the written stroke of the follower. After this, for the next 60 degree, there is no motion of the follower. It means the follower will be under rest. It means the displacement will be zero. Just continue here. So I'll draw one more straight curve. It means the displacement will be zero. The angle will be 60, but the displacement will be zero.
Dwell.
Dwell, correct, correct. So this completes the displacement diagram for the given problem. The only changes is previous to, when you compare it to the previous problem, that is problem number 2, I have interchanged the conditions. In the second problem, the outstroke was with a simple harmonic motion and the return stroke was with uniform acceleration and the retardation motion. But in this problem number 3, I have changed the condition. The type of follower motion is changed. It means the outstroke is with uniform acceleration and the retardation, and the return stroke is with simple harmonic motion. That's why the method also you have to interchange. You have to change the method. It means whatever the method that is used for simple harmonic motion, it will be semicircle. You have to use that method only. Only this is the change. Okay. And since for the outstroke the curve will be moving upward direction, I'll draw the diagonal in upward direction. It means from left bottommost corner to right topmost corner. If it is coming down, you have to start from here. The diagonal will be in a downward direction, which was the case of problem number 2. So if it is clear, I'll go to this CAM profile in the tomorrow's class. So this is very much important. Don't miss tomorrow's class, because in the examination this problem will be repeated. The roller type of a follower will be repeated. Okay, there is a slight change in the method. There is a small change in the method. Okay, the tomorrow's class I'll continue with a CAM profile for both radial follower as well as the offset follower. Okay, so if any doubts, you can ask me. Otherwise, I'll wind up today's class. Okay, thank you.